Welcome, ladies and gentlemen, to this video lecture. Okay, so now we are heading to a new section on the fundamental theorem of calculus. So the fundamental theorem of calculus comes in two parts, and its aim is to make rigorous the statement, or let's say the informal statement, integration is the opposite of the derivative, or in reverse, derivation is the opposite of integration. So the fundamental theorem of calculus, its aim is to make this statement rigorous. So in our calculus courses, we tend to apply the fundamental theorem of calculus to compute integrals. So now we will study the fundamental theorem of calculus itself. So let us start with theorem 4.3.1, and this theorem essentially says that integration is the opposite, or is the inverse of derivation. Okay, let us take a look at this theorem. So if we have some function little f and big F, we have two functions defined on a closed interval a to b to r. Little f is continuous, big F is differentiable, and the derivative of big F is equal to little f for t in the interval AB. Then, if we compute the integral of ft dt between the bounds a and b, that is then equal to what is called the antiderivative evaluated at b minus the antiderivative evaluated at a. So essentially what this says is, if you're trying to integrate a function and you know some function whose derivative is equal to that function, or in other words, if you know an antiderivative of little f, you can work out the integral of little f. And what is the integral of little f? It is, you take any antiderivative of little f and you evaluate it at the end points of your integral like that. And I often have a slip of the tongue. I say the antiderivative, but there are of course infinitely many antiderivatives of any function which has an antiderivative. Why do we have infinitely many? And this is where your constant of integration comes in. So the constant of integration can be anything, and if you think about it, the constant of integration will get cancelled in that in this difference here. Okay, so this is what I call the form of saying integration is the opposite of derivation. Okay, so this is the first part of the fundamental theorem of calculus. We will now move on to the next part, and we will actually prove this part. We have developed all the tools that we need in this course to be able to prove this part. So this is theorem 4.3.2, the fundamental theorem of calculus. The fundamental theorem of calculus. And I'm going to put here in brackets, what does this theorem say? Just in informal terms, it says that derivation is the opposite to integration. And this previous form said integration is the opposite of derivation. So just take care, that's not the same statement. Okay, let's write down the statement of our form of the fundamental theorem of calculus. So let f be defined on the closed interval a to b to r. Let it be continuous. Then if we define then with big F, capital F, defined on the interval a b to r, defined as what? F of x is the integral from a to x of little f t dt, and this is for all x in the closed interval a b. If we define our big F as such, then f is continuous, and it is continuous everywhere on the closed interval AB. F is differentiable on the open interval AB. And what is the derivative of f? The derivative of f at any point x is equal to little f of x for any x in the open interval AB. So let's take a look at this theorem. It says if you have a continuous function and you look at its integral from a to x, so if you look at this integral and you define a new function where the parameter of your function, or the variable, or let's say the input variable of your function, is the bound of your integral. If you define capital F as such, then capital F is continuous, it is differentiable, and its derivative is equal to little f. So in this sense, it says that derivation is the opposite of integration. So here we define our f as this integral, and if we now differentiate this function f, we get back our function that we actually integrated. Okay, so that is the statement of the fundamental theorem of calculus. And in the next couple of video lectures, we will actually prove this theorem. I will see you in the next ones.